Welcome, welcome, welcome. It's Saturday, and we're going to learn to program properly. Yes, learning to program here at Amberskies with Bladez. That's me. Oh, wow, I'm here. Hi. Ah, lovely. What are we doing? We're doing Java. Interesting language, I've got to admit. We're doing a 3D game engine in Java. And today we are going to find out why I never do a 3D game engine in Java. Oh, this is going to be fun. Yeah. Let's get me files open. Let's get me notes. May as well teach properly. I've actually done a script for today instead of just winging it. So if we're lucky, we might just get something done that's useful. Yeah, because Java and OpenGL, that's the 3D bit. So how does this work? Let's get a pen and find out. We got a pen? Yeah, we got a pen here. Excellent. Let's just get the pen over here. Okay, let's explain what we're going to do. This is going to be fun. First of all, we are going to be using OpenGL. And the first question you're going to ask is, what the heck is OpenGL? It's the open source graphics library for 3D or graphics cards. How it works is the manufacturers get together every year, decide what OpenGL requires, and then hard code that into their graphics cards. I think that's the best way of putting it. Yeah. Alright, so it's up to the manufacturers, and there is a team who oversee OpenGL as well. And they then write the specifications. The manufacturers try and stick to those specifications and produce drivers so they can. And inside those drivers, you will find pointers. To the graphics card hardware. And that graphics card hardware is fixed. It's very fast. It's blazingly fast and can run 3D graphics. So OpenGL is a set of pointers that's held in the driver. So your driver, NVIDIA, AMD, whichever driver you use has all of these pointers in. And what we do is we reference our graphics card using these pointers, or what we call commands. And you can always tell, usually with OpenGL, because it starts with GL, I believe, yeah. So a command would be something like GL and then a capital. Well, no, it's enable in lowercase. So that's the kind of command that you're going to be looking at. And it comes from your drivers and your graphics card and everything like that. So this gives us direct access to three-dimensional graphics. And we're using Java to do it. Normally I would use C++, and I would advise anybody who wants to seriously learn three-dimensional graphics to, after completing this teaching course, or whatever you want to call it now, I would advise you very, very strongly to think about using C++ and repeating everything that we've done in translating it into C++, because that's exactly what I did. So, Java. It doesn't play fair. It was never designed for 3D graphics, was Java, and doesn't have pointers. Java doesn't have pointers, and, well, that creates a little bit of a conflict with OpenGL and the way in which Java handles arrays, especially, will conflict. We'll have to mess about a little bit to get it to work. Not a lot, but we will have to do a little bit of extra work to make OpenGL accept what we want as input, like a 3D model or whatever. So that's what we're going to be doing today. We're going to be configuring Java for 3D. In other words, we are going to start the rendering mechanics, or I suppose that's what you could call it. Right, this microphone's not in the right place, and I've got a cat sleeping on the feet of the microphone, so, oh well, we'll just move the microphone that way. Okay, that's fine. That's fine. I'm going to leave the cat asleep. I hope you're alright with that. Any questions about OpenGL? If you need more OpenGL explanations on how it works, I'm more than happy to stop the coding and sit down and teach OpenGL from scratch. I don't mind, but it's nothing to do with programming, really. OpenGL is just a big, long list of pointers. That's all it is. It's not even a language. So don't be fooled by it. It doesn't actually do anything itself. It has to be used by another language, like Java. Alrighty. I think we can just pop you up out of the way. Oh God, we're on part 5. We've got a very, very basic maths library now, which is going to help us immensely. We've got a couple of basic functions in there. We're going to have to write more, obviously, as we go along. We've got our main component. We've tested all of our maths with basic tests. I would advise people try and write better tests, but there we go. That's good practice if you want to do that. When it comes down to testing, there is a philosophy that you should test everything, and that's not quite correct, because what we're going to do now you can't test. Not in a unit test anyway. You can test it though using something called an end-to-end test. Well, we've already got one. It's called main component. It's here. This is our end-to-end testing. This tests everything that we've written, and everything that we are going to write will either be run in here or run from here. So, or should I say executed in here and executed from here. So this is the main area, and I'm also not happy about something I thought about. I'm in the main component, aren't I? Where is it? Got shut down render. Public window, blah blah blah, main components. Where's my main gone? Oh, it's here. Alright, I just ran a quick format before I started, so it's moved my main up here, which is where it really should be. That's clever of it. So yeah, move your main up to the top of the file so you can find it, because that's your execution point. That's where we start executing from. So run main component, and dun da da. Did anything happen? No. Oh well. Ah, yes it did. It just took its time. So there we go, that's our main component. So what we're going to do is we're going to set up OpenGL. And there's very specific, there's one major command that we need to include because of GLFW. And the GLFW integration into our program. GLFW we use to do the window, and it also enables us with the video mode to make what we call an OpenGL context, and that's what this is doing. This links through to OpenGL, but there's another command. There is an extra command that we need that goes with that context, and that is coming up next. Main component, do I need it? Yes, I do, because I can't test this using a unit test. Right, let's get going, and we want a new Java class. What we're going to call this one? How are we doing for people? Oh, we've got an actual viewer. Hello, viewer. Hello to you, my viewer. Oh, that's lovely. I'm going to start with a render utility for our rendering. So I'm going to call it, believe it or not, render util. There's the class. Do you want to add the following file to Git? Yes. Add. Thank you. Now, did it do all of my thingies? Yes, it did. It did all of my brackets, didn't it? So I'm not going to change my brackets again. Alright, fair enough. Right, this render utility is going to give us two functions to start off with. We're going to have a public, or two methods. It's Java. Use a word method. Public static, which means it can be accessed from the outside. Static means it will be transferred in place. Void means it's not going to have a return value. And this is just going to init graphics. I usually say GFX, don't I? For 3D graphics. Yeah, GFX graphics, because that to me means 3D. I could put 3D GFX. No, I won't, because I know what GFX means. Alrighty, so that's the first one. What else will we need? Oh, it needs that thing going up to the top now, doesn't it? Yeah, because we're using that thingy. Alright. I don't like it done that way, but hey ho, that's the way this IntelliSense works, so I will do it the way the integrated development environment does it. The other method we're going to have is public static, so it gets transferred into place. Void doesn't return a value, and all we're going to do with this is clear the screen. That's all it's going to do. Very important. There we go. So let's initialize the graphics first, because we can't do anything unless we've done that. This is the next thing that you need. First of all, you need that GLFW create the current whatever it was context. which OpenGL needs because it's a state machine. And the next one it needs is this. It's going to need GL dot create and its capabilities. I don't want debug. Just want the OpenGL one, please. Right, yeah, okay. We'll have that one. Lovely. So that will now activate OpenGL. As long as you're okay with that, we're fine. That's all it does. It just literally says initialize OpenGL for Java. That's all it basically does anyway. Now here we come with some weird GL commands. So clear color. What we're going to do is set the background color for our window. Now to test that it works, we're going to use a color. And colors, we're going to use floats. So it goes from 0 to 1 and is up to 6 decimal places. Now we know we can only do calculations to 4 decimal places. So keep it to that accuracy, you should be fine. I will have an R red 1.0 and it's a float. I'll have 0.0f, comma, 0.0f, so that's RGB. And we are going to have an alpha channel. Theoretically, that does blending with the background, the alpha channel. So on the graphics card, that should do transparency. Oh, we've got multiple choice, have we? Okay. So Alt plus Enter, what's our multiple choice? We can use GL11. What's the difference between the top one and the bottom one? Don't know. I'll take the top one. There we go. So it fills it in for us now. And I've just been stupid because that should be red, green, blue, and alpha. So it reads right. I write downwards, not across. So that's the first command, which will set the clear colour for this clear screen down here. So how we clear the screen we'll do in a bit, but next we need the next command. What else shall we have? Okay, OpenGL goes counterclockwise. Okay, so I want to, in Java things don't really go counterclockwise very easily. So I think I'm going to reverse that and make it clockwise. Alright, so GL. Front face. Front face, yeah. And we are going to go clockwise. So GL clockwise. There we go. And that's it. Alright. So all we're doing is we're saying that the front face, or the face that faces the camera, will be drawn clockwise, which means you've got to get your triangles, the 3 points of your triangles have to be drawn in a clockwise rotation. Lovely. In C++, I wouldn't bother. I'd just leave it as counterclockwise, and I wouldn't care too much. So that's our front face. Now the back face we don't want to draw, and in OpenGL that is called cull. So cull face, and it's going to be GL back. You're probably wondering, why would you not want to, what would GL front do? Well, it would show you all the back faces. So if you had a box, for instance, and you got into the box and all the box size disappeared because you were culling the faces, you might want to turn that off. It's just something to think about. We will enable it. GL enable. What we're going to enable? We are going to enable GL cull face. There we go. So these are OpenGL commands. What else can we do then? We can enable other stuff. So GL enable. Let's enable a couple of things here. I will enable the OpenGL depth test. Now, if you want me to go through depth testing, actually I might stop and explain that one. How does depth testing work? Let's just hold on that thought for a minute. Cull face just means don't draw it. In other words, it halves the time to draw anything because you're not doing the back faces as well as the front. Depth testing has a buffer. What we're asking our graphics card to do there is to use the depth buffer. So let's just click this on so I can write. So we have a depth buffer. Which is every single pixel on the screen. Okay. Every single pixel on the screen. So that's your screen X, window X. No, that's window Y, isn't it? And X, and this is in pixels. The depth buffer sets everything to 1. This is an example. Okay. When we pass a pixel, well, when we pass our data through the graphics card, the graphics card will then do a depth test. And what it will say is it will crush everything in the scene into a box. So you'll have a box like this that goes from 1 to -1 with 0 in the middle. Okay? And that's usually the camera position. So I will say that that is C. C equals camera. So you got the camera facing the 1. Make sure those look like 1s. Okay. And if something is closer to the camera, the depth test just says is the pixel or is the face closer to the camera? So it's a less than 1. And if it's less than 1, that pixel gets placed. So if less than 1 pixel value distance, from camera. Gets placed into one of these things up here. Into one of these, well, wherever the pixel is. So these will go down, and they can go down as far as 0. Anything that's is minus gets discarded. Anything that doesn't meet the depth test gets discarded. But everything starts at a number, and then it just gets close. These just go down and down and down and down and down until the right pixel is drawn in the right place. And that's the depth buffer and the depth test. That's how it works. It's that simple. It just tests whether a pixel is closer to the camera than the number that we've already got, between 0 and 1. And that's how it works. It's a nice, simple system, and it's fast. Very, very fast. But now you can see why 3D graphics can slow your computer down. The more graphics you have on screen, the more pixels, the more times it's got to test for depth, the slower the scene will render. Or raster, I think they call it at that point. God knows why. Why do they use such strange language? But that's the basics of depth buffers. And I mean, it's just the basics. Overview. Alrighty. So I've done that. Magic. Shall we have another command? Yeah. So we've enabled depth. There are 2 types of depth, but I'm not even going to mention those. Yes, I will. There's perspective and there's orthographic. But anyway, just does different things. So, with the camera, that is. What should we enable next? We've got our depth test. That frame buffer. Let's tell it how we want to use that frame buffer. So, we will GL enable. Again, this is something I wouldn't do in C++. And this would be GL frame buffer. Frame buffer. Come on, find it. He hasn't found it. sRGB. I want it that way around. Well, it hasn't found it. Why not? Because it's in OpenGL 3. Well, actually, it's in OpenGL 15. Can it find it? Oh, it can maybe. ARB frame buffer. Which one's that in? No, I don't want that one. I'll take this second one down. It's got C in front of it. Nope. I'll take the bottom one. Yeah, I'll take that bottom one. There we go. All that does is it inserts this here. Yeah, that's fine. Just wondering if we need that OpenGL now at the top, but it says it's using it, so I'll leave it alone. That'll do. I think that will set up our screen. Alright. The only other thing I might do at this point is do a system out. Yeah, system dot out dot println. Yeah, whatever. OpenGL. add to that the GL get string. And we will pop in there, actually. Yeah, okay. We'll see how this works, shall we? I'm going to put something in that get string, please. I want to put GL version. So it's obvious what that does now, isn't it? And that should be correct. What do you want? Major version? No, I just want the top one, please. Thank you. And that's it. I think we are out of commands. Not sure. No, that'll do. That'll do. So it's OpenGL plus GL version. Alrighty. So that's going to place out the OpenGL version to our console. Let's test it out. Where are we going to put this? We are going to put this into our main component. Here. So that's going to go in here. You see, we can't really test it, as you can tell. There's no way that I could write a test that I know of offhand to do that. We just want to hit the graphics, please. So the only way I can test it really is with that console output. So let's have a look, see if we get it on our console. There you go, OpenGL 3.3 core profile forward compatible. Yeah, that works all right. Coverage. Oh, did I click the wrong thing? Oh dear. I don't really want to hear about coverage right now. That's something completely different. So that's the only way we could really test it, is by doing that. Now, I changed the colour to red, but that window wasn't red. Why not? Because we're not clearing the screen. You won't change colour until you clear the screen. So let's do that. And that's going to be GL clear. Is it just clear? Yeah. And it says int mask. So let's mask this up. We will want the GL color buffer bit. Remember, I showed the diagram of the buffer and it just goes from 1 to -1, but it just says 1. So all the bits. And we can OR that with GL underscore what? Depth. We want the depth doing as well, don't we? Depth. Buffer bit. And that should do it. So those two. That's fine. So now if we clear the screen with that being red, we should stop getting a black screen and get a red screen. We just have to put it in somewhere and it will go into our render method. So if we go down to our start render method here. So before we do anything, we clear the screen. Before we do any rendering. That sounds fun. Let's do that. Render util. Dot clear screen. That's it. So now we should get a message telling us that we're using OpenGL 3.3. Why 3.3? Because that's what I asked for here in the window. So that's our context version, major and minor, so it's 3.3. GLFW core, OpenGL core profile. So it should be 3.3 core profile. And let's just run it. Where's the normal run? Ah, there it is. And we should get a red window. There we go. And it's 3.3. Let me just hold that stop. So it's 3.3 core profile forward compatibility with a context of 22.19.162.4. That's its context address for OpenGL. And we have red. So we can change this to whatever colour we want. Most people do it to black. Don't use black, ever. Please. The lowest light level I want the screen to go to is 0.1. No. I'll use 5% light level for background light. You can treat it as a percentage. So 5%. I don't know what happens if you change this one, but we can find out. I doubt it'll do anything. It might. No. It just adds, seems to add the colour from the back. Doesn't look too dark to you, does it? That? So if we... I think that gives it its effectiveness. Let's try that. That's too much like grey to me. Did we turn blending on? We haven't, have we? That's why. Okay. No, we haven't enabled blending. I don't think we've enabled it in the window class. So let's just check. Create window. No, we didn't do anything. We just showed the window. We didn't do anything here at all. Some people put the initialization for GL in here on that line. It can be there, but I think I prefer it separate because we are going to be obviously adding to that. We're going to need blending and stuff. But there's the only way you can test it really is by trial and error a little bit. So I'm going to put another 0 on these. See if we can get it a bit darker. That's a bit better. No, it's just a very, very soft, hazy grey. Alright. What I'll do then is I'll put you to 1. And I'll put you to 2.5. Let's try that. That might give us a nice background shade. It's not black. Yeah, that's come up. That's not black. Just slightly red. Definitely not black. That's black. You can see the difference now. Put that back where it's supposed to be. So, yeah. That'll work. It's dark enough. Lovely. So that's our render utility. And we've added that. We've tested it with the end-to-end test of main component, using main component. It passes those tests as far as we can tell. Whether it's done enabled all of this lot, I can't tell you until we do some rendering. We just have to wait on that one, I think. So that's that. That completes the OpenGL basic setup. Let's see what we can do next. What do we need for meshes? Or what do I mean by a mesh? Right, 3D objects. Let's do the basics of 3D objects now. I love this. I love 3D. Alright, grab yourself a pen. And a 3D model. Is equal to a mesh. We call it a mesh because if you just draw lines between each point on the triangle, it makes this kind of mesh type thing. So yeah, that's why it's called a mesh. A mesh is comprised of a number of triangles. So that is equivalent to a number of triangles with points on, or locations, positions, whatever you want to call them. We call them vertices. That is, now that's a face. That is the face. That is a vertex. And we are going to be drawing them in clockwise. So each one of these lines goes that way. That's clockwise. So we have to draw them in that rotation. And you put all of these together, it makes a mesh. All the faces are then either coloured or textured, and it makes a model. Very simplistic. It's Lego in 3D. So instead of using Lego blocks, we use triangles. So one Lego block equals one triangle. That's how I spell triangle. So yeah, you can get the idea that we build up our model out of triangles. The more triangles there are, the longer it takes to build the model and draw the model. So they call them low polygon because models, those are the ones that have the lowest number of triangles. They call them polygons because you can have triangles or squares, or quads, should I say. But we're going to only deal with triangles. Because draw elements only accepts triangles and not quads, as I found out. So we're only dealing with triangles, that's all that concerns us. So models have to be in triangles. So that's what a mesh is. How are we going to define that in code? Good question. Let's start with the vertex. It might be better because that's the smallest unit that we are going to be dealing with. Go back to a pointer. I think a vertex is a good place to start. So let's start there with a new Java class called vertex. V-E-R-T-E-X. That's a good one. Ding! We'll add it to my Git repository. Thank you. The first thing we are going to define about our vertex is it is going to be comprised of three things: an x, y and a z component. That's going to be its position in 3D space. So I'll get the pen back. Right. So you have two-dimensional space, which is x and y, and then on three-dimensional space we have z, and I think that's coming straight out of the screen towards you at right angles to these two. These are all right angles, and that's the third right angle there. So z, think of it hitting you in the forehead. That's going to make all our... yeah. So put your thumb on the forehead and your fingers are the direction of rotation. So that'll be clockwise. Wow. It's left-handed. Okay. And that will be left-handed. So put your left-hand thumb on your forehead and point it at the screen, and your hand fingers will tell you which direction of rotation you get. So it's a left-handed, which equals clockwise rotation. Because that's what we've asked it to do. We asked it to draw clockwise for our triangles. So that's that. Oh, we've got a visitor. Alright. I'll be doing my stair lift, I hope. Alrighty. So that was a little bit of an educational bit. I'll just put that as an aside there, and we'll concentrate more on our vertex. I was trying to say a public static final size, wasn't it? Really. So that's going to be a public static final size in capitals, because it's a final constant, equals 3, and x, y and z. Public static final size equals 3, semicolon. Alright, I don't know why it's underlined like that, but okay. Unexpected token. Int. Sorry, my bad. That's an integer. Notes, you're daft, you're wrong. Int, please, thanks. What else will we need? We'll need a private vec3 position. So x, y, z, a position. It's a vector 3. And that's going to be equal to, well, whatever it gets put to, I suppose. Now, we are going to have a constructor. Public. And that's going to be a vertex. And it's going to take in a vec3, because that's what we've got up here. It is is it a capital V? No, it's a small v. Yeah, that's why it's red. Yeah, that's better. It's going to take in a vec3 position. POS. Okay, we can't write anymore, remember? We're doing testing. So how did I do this? Oh, wait a minute. We need all of the getters and setters as well, don't we? If I remember rightly. So I can put those here. That's an Alt Dubry. No, it's just right click. Generate. It's Alt Insert to generate. Getter and setter. You can't have the top one because it's a const. It's going to be 3 no matter what. So it's just that. That generates our getters and setters, so we don't need to test those, but we do need to test this. So is put it on the class, vertex, Alt Enter, create test. Here we go. JUnit 5, vertex test, blah blah blah. No. No. Get and set, I'm not testing. Okay. Do you want to add the following file to Git? Yes. I want all my tests to be stored. Okay. So it's at, what am I doing? It's alt insert, test method, and the name is going to be vertex constructor. Okay. How do we split on here? That's better. There we go. We can see the vertex constructor now. It's empty. So what I'm going to do is I am going to take a victim. So a vec3 victim equals a new vec3, and position we are going to put in a vec3, and we are going to call it 1.0f, comma 2.0f, comma 0.7f. Semicolon. Is that correct? No. I don't think I need... I've doubled up on myself here, haven't I? Yeah. There we go. That's better. Right, so I've now got a new vector3. What we have to do now is use our getter to make sure that those values are correct. So, it's going to be... Was it assert, isn't it? Assert true. Condition. So, let's see. I can't see. It's 1.0, yeah. 1.0f. Oh, sorry, no. It's a condition, isn't it? That's right. So it's victim dot getX is equal to 1.0f. That's it. That's what I want. It's got to be true. Will we come across that horrible, horrible, horrible floating point error? We should do, I think. Theoretically. Now we know that our vector3 is okay, that's been fully tested. But I need this testing as well. So let's run this test and see what happens. We should hopefully fail. No, it didn't. You can't do it without. Oh, wait a minute. Am I allowed to do that? No. It has to take a value. Oh, that's a shame. How do we get a negative test then? Because our setters and getters can't affect anything because they're generated. All we can do is... Ah, wait a minute. We can do a result, can't we? Yes. Control Z, Z, Z. Alrighty, let's try this then. Vec3 result equals victim dot get pos. Why can't I do that? It creates a new one. It returns... Ah, no it doesn't. Alright, let's have a look, see what we've done here. Equals... Oh god, what have I done? Vertex dot... No. I've forgotten how to do this. Oh god, it's only been what? A week? And I've already forgotten how to do my testings. How are we doing it? It's usually the first one, the constructor, isn't it? So why can't I get pos? And set pos. Have I done something silly? I've got to break it. How do I break it? Vec3 0.0f, comma 0.0f, comma 0.0f. Let's do that. Let's put space in there as well. Thank God. Right. I'm also worried because now that's a different colour to that one. So result get, where's get position? can't move it now. Alright, so what was map 4 doing on the multiply that was different? Return result. What's our vector do? What's our vertex doing that's different? Ah, voiding. Oh, that's on a set though. I want to get that position. How do I get it? Public vec3. This is... Java does my head in. It really does do my head in. Why can't it just be so simple? Yeah, welcome to teach you how to write in Java when it doesn't work. What is going on? How do I get the position then? I see. Sorry, I'm an idiot. For starters, I'm testing vec3 here, and not vertex. Vertex. That's what I'm doing wrong. Victim has to be a new vec3. Incompatible types. Alright, that's okay. Vertex. And that's a vec3. Yes. That should be correct. Interesting. As I learn to program the hard way, equals victim dot, there we are, get position. There, semicolon. And that's an error. Alright. Right, well this needs a vector 3, doesn't it? So let's give it one. Vec3 position equals a new vec3. Cut. Paste. Position. Okay, we're satisfying the rules now for Java, except for this last one. Incompatible types. Found vec3. Oh, right. Yeah, it's returning a vec3, not a vertex. And now we can change all of these to result. Copy. Paste. 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 Run a test. Please fail. Yes! Constructor failed. That took a bit of doing, but we've got it to fail. Why did it fail? Well, we've told it all the information, but have a look at the colouring. That gives it away, really. That pos is used there, there, and there, but not there. You can tell just by the colours. That's purple, that's orange. So that is a variable that is being passed into vertex, and this is a variable which is part of vertex already. So what we have to say is that this dot pos equals the pos that's just being handed into us, like that. So the purple one is equal to the white one. It's gone white now. And now when we do run our test, please work. It works. So we've gone from failed to green. We have tested it. The constructor works. Thank God. Right, it seems as though I'm getting my testing boots back on here, doesn't it? I'm a bit slow, but hey-ho. I just need more coffee, that's what it is. La 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 la. Oh, fantastic. We've got our first test over with for the day. I feel better now. What else do we need? I think I'm going to just leave it at that for the vertex for now. And get myself a drink. And then we'll get on with the next bit. So we've got a vertex, yes. And we've got it fully tested, yes. Again, you should really do more tests than that. Possibly with random numbers or even random number generators in there and everything, absolutely everything in there that you can think of. Because it is important. It is very important to keep on testing. So that's our vertex tester. That's okay. That's okay. That's okay. Alright, next up, we are going to create a new Java class. This time we're going to go to the next bit upwards in the chain, which will be the mesh. So let's have a mesh in here. And we'll have you here. Add. Thank you. What's the mesh going to have? Right, let's start at the top and work it all out. Notes. What do we want for a mesh? We will need a private int. And it's called a VBO. Right, we may as well get rid of this then for now. Right, let's just concentrate on this. VBO. Great, what's that? Well, it's a private int for one thing. Pen, please. And that is, sorry, that is a, let me just move this microphone so I can actually reach the pad. So that's a vertex buffer object. But hold on, Blades, in C++, this is a, we need to make this into a pointer, don't we? We need addresses and stuff. Well, yes, you do in C++, but this is Java. It doesn't do that kind of thing. So it's just an int, VBO, and that's it. That's what you're going to get. This is where we are going to place a handle. Because we don't have pointers. Is it DLE? Yes, DEL. Sorry about that. So we've got this vertex buffer object, which is a handle. What's a handle? It's just a number. Like 0, 1. The first number that it's probably going to be is 1. So the first VBO that our graphics card will give us is the number 1. And the graphics card will remember that number 1 is equal to all of the number 1 VBO is the vertex buffer on the graphics card where all of the data for the vertices will be held. And that's what we're going to use a VBO for. We're going to hold all of our vertices in a vertex buffer on the GFX card. So that is a handle to the graphics card. Location. For our vertex data. So all our vertex data is going to be placed on the graphics card, and wherever it's placed on the graphics card is going to be, the graphics card will say, right, I've placed it here, you're the first one to come along, so you can be number 1. And the next model will get VBO, or the next thing will get VBO number 2, and the next thing will get VBO number 3, etc, etc, etc. And the graphics card will remember what number refers to what location on the graphics card for the data. That's nice. No pointers. Very clever. Right, so now we know what a VBO is. It's just a load of vertices. So there we go. That's a VBO. What's the next thing we need? We're going to need a size. The VBO is going to, we need to know the size of it. And it's going to be in bytes, isn't it? Yeah. It's going to be in bytes. I think. Usually is with OpenGL. So private int size. go. We'll have those two. Alrighty. Will I need getters and setters for this? So, public. Mesh. I'm having difficulty with my fingers. Come on, work you darn it. I'm going to try for some getters and setters here. Would you have any? Would you really use any? No. You might want to get the VBO, or you might want to get the size of the mesh, but you wouldn't want to set them. I'm going to do that automatically. So getters is the only thing I can think of. Getter. Yeah. I'll just have the getters. So get VBO and get size. Otherwise I'm not going to be able to test this, am I? Oh, this is an easier test. Mesh. What was it? Alt insert. No, it's not. It's alt return. Ah, there we go. Create test. Here we go. No. That'll do. Okay. Add. So, we're back to this again, aren't we? Split, please. Thank you. Bye-bye. Alrighty. So, no, just don't do it that way. Alt insert test method. Test name will be mesh constructor. Mesh constructor. And this is going to be really easy. So mesh, we'll call it victim. As the first one I always use. I don't know why I use victim, but it just pleases me immensely. Sorry. Should call it prime, really. Equals a new mesh. Okay. That's legal. Assert true. Darn it. Assert true that victim dot get VBO is equal to 1, because that's what I'm guessing the first VBO will be, so I could be wrong. Assert true victim dot, what's the one, get size will be equal to 0. That should be true. I think. I could be wrong. Alright, okay. Alright, well that's an integer, isn't it? So we can do assert equals expected 1, comma, actual, that. Yeah, so I'm going to use an assert equals for that. Definitely. And that has to be true. So that's a bit of a guess. Let's run it and find out. What we're trying to do is fail the test, remember. We're not trying to pass the test here. Good, it failed. Oh, which one did it fail on? Right, well, I don't know, is the answer to that. So it failed, which is good. That's exactly what we want. Now we have to try and make it work. Right, what code do we want in here to try and make it work? Let's see, meshes. We'll want the VBO to be equal to something. How's about GL gen buffers? I think that's the code for it. I don't want glares. GL15 looks okay. I don't want debug, so it's that one with a C on it. Hold on a minute, that C means something. Window, please. What does that C mean? I wonder if it means compatibility. Or does it mean core? As I'm uncertain, I won't use it. What? No. Come back. Alt plus enter. I will use probably the first one. Yeah. GL 1.5. Yeah, that'll do. That'll work. That's got a red on it. Okay. So it was that one. And we need to set a size, which is easy to do because we know it starts at nothing or 0. Run constructor. And the constructor says, oh, fatal error in native method. No context is current, or a function that is not available in the current context was called. Right, so we can't test the VBO. The VBO can only be tested by main component or an end-to-end test because we haven't got a current context, we haven't run a window. We could make a window. And that will give us a context, but it won't give us the initialization. And then we'd have to delete it afterwards. That's the at startup and at strip down thingy that it gives you as choices. So you'd have to copy that. To there. That does have to be in inverted commas. Oh, I think it does, yes. So that's that. enter there. Why can't I Alt plus? Alright. Where's window? Copy. Import. Dot. Window. Dot asterisk. That should work now. Why can't I do that? I know why. You can't put it there. It would have to go inside the test itself. There we go. Right, so that creates a window, sets the context. We also need render utility. Render utility dot initialize GFX. Then you can run your tests. Then, do we need to get rid of this? What do we do on shutdown? Window.shutdown. And that's all we're doing. Okay. Can you just click? Thank you. So it's just window dot shutdown. Right, is that correct? Yeah, it is. Silly me. Right, so that should give me the context for doing the assert equals on the VBO. It will also flash a 200 by 200 window up on the screen for a second. Interestingly. Alrighty. You can have that. That's okay. There we go. And it worked. So my assumptions of that being expected as 1 was correct. Okay. So I'm going to put a note in there for that. Clever. I like that test now, because that test has now shown that you sometimes have to go further to make a test work. But going further than that, I don't think I would. Those are the values. I don't think I can test it any other way. So I think we're stuck with that for our mesh. Our mesh has been tested. and has green. It's come up green. Where's he putting this mesh test thingy? Is it in here? Ah, yeah, there it is. Oh, fantastic. So all my tests are here. Means I can run all of my tests. Am I allowed to do that? Run tests. So what does this do? Oh, wow. Look at this. Every single test can be run. Fantastic. So that means that if I make a mistake somewhere, I can look at the tests to find what the mistake is. That's fantastic. So this now gives me confidence that the mesh is being constructed properly and is giving me the correct results. That one you probably wouldn't check for because it's an OpenGL thing, but I knew it was going to be one just from experience. So that's an experiencey kind of thing. But I have had to add a note there, which I don't mind. Right, what else do we need on this mesh? Anything? How's about we try to add vertices to our mesh? That could be fun. Let's try it. Alright, what will it be? Public void. What should we call it? Just add vertices, I think. Yeah, that's right. That's how you spell it. It will be a vertex of whatever. Vertices. So that's what we want to happen. So with this, we're just going to be able to test size. That's all really, isn't it? Alright. So if we add vertices, the size should increase. Alright, we'll try adding a vertex and we'll see what happens. We'll take a blank mesh, a blank Dubry. Let's see, alt insert, here we go, test method, and it's going to be called mesh underscore add vertex. Vertices is plural. Alright. Well, as before, we're going to have to do the window thingy. So we'll take this lot and copy it. And we'll start with this test and work our way through it. Okay, so we're going to get that, yeah. We get a mesh. Right. We know that that's true, and right, so that's the one we want to take out, because we're not going to be doing that one. Or we could leave it in. It's not what we're testing. Right, it's an equals. Yikes. Is it though? Well, I'm going to have to work it out, aren't I? Equals. We're going to have a number, comma, and it's going to be victim get size again. So I don't... Oh, can't put that in. We need to know what we're going to do here. Let's have a look what we're going to do to our victim this time. We are going to add vertices. So victim, we're going to need a vertex, aren't we? All right. So vertex prime equals a new vertex. And we need a position, don't we? Vec3 position equals a new Vec3, and we'll just put it equal to 1.0f. Doesn't matter what we put in here. 2.0f. Well, no, it doesn't matter. 3.0f. It'll all result in the same size calculation. That becomes position. And what we are now going to do is add position to our mesh. Okay. So victim. Actually, just pop a line in there. So victim dot add vertices prime. Now, why would that not work? Because we are asking for an array of vertices. So vertices is going to be something completely different, isn't it? It's vertex prime. Does it come on this side? I think it does. Alright. Array initializer expected. Oh, right. No. Prime 1 equals a new vertex, open brackets, position. Why can't I access it like that? Java does its arrays differently, doesn't it? I mean, this is one of the problems we're about to face. And didn't I face this problem in Windows as well? I'm sure I did. Alright, Right, it's just looking for a number then, isn't it? Um, 10. Doesn't really matter to me. Right, now it works. Excellent. How to program in Java. Good grief. Too many news. Too many news. Let's see what we need to do now. Victim add vertices. Prime is working correctly. So we want to get the size. What will the size be? Gosh, that's a good question. Do I have the size here somewhere? I might have the size. Thingy. Right, so it's vertices dot length. So it's 1. So it's 1 vertex length. What does length give back? Victim.length. What does that actually give? For some reason it doesn't give anything. Why not? Length is... I thought that was an array thing. Ah, right. It's prime I want. Prime. Dot length, yeah. So what does this give? Not a statement. Intex. What does this do? F1? Where's length? That's useless. Okay, don't know. Refactor, fold analyze. Analyze? Search with Google. Search with Google? Really? Dee. It just seems to be an integer, but an integer of what? It's talking about prime numbers here for some goddamn unknown reason. Oh well. Never mind. We'll skip that bit. So, why is intex red? Oh, it's never used, right, okay. So that's that bit. What would it be multiplied? It'd be multiplied by 3. Times 3. So expected x. Assert equals x. Victim.getSize. Alright, let's try that. We're going for a negative anyway. We're not actually... we need to generate the buffers though. Alright, let's just try running it and see if we can... whether it'll work or not. Alright. Expected 30. Float is 4, I thought. 4 3s are 12. Times 3 is 36. So I would have put 36 in there. But obviously not. That's interesting. How can you get to 30? So it's 10. The prime dot length is 10. And it's 3 numbers. How can that be? That's mind-boggling. The length is 10. That's impossible. Alright, well it failed anyway, so let's see if this works out or not. I have no idea if it will. So we have to add the vertices and then, well, check its length. So I know what the size equation is already, obviously. But, right, okay. So what do we got here? We've got size equals, and it's going to be vertices dot length multiplied by vertex dot size. That's correct. That's the correct equation. Now all we have to do is put those vertices into the buffer. So GL bind buffer. The first thing we have to do with OpenGL, if we want to use a buffer, we have to bind it to make it the current buffer, so that OpenGL knows which one that we are referring to. So GL bind a buffer, and that's going to be type of buffer, which is a GL array buffer. Good. And the VBO, which is number 1. GL array buffer, you see, vertex array. So that's what it is. It's a buffer of these arrays. Yeah, it all matches up in the wording. That's the nice part about Java, is that the wording matches up with the well, as you construct things. So that's rather nice. Now we're stuck. Now we are stuck. Totally. Because Java doesn't work on the next command. The next command that we want to do is GL buffer data. That's our next OpenGL command. And what we need to put in here is that it's a GL buffer. Why is it not coming up with array? Oh. GL buffer array. It knows what that is, and it's just playing silly thingies there. Well, this is where we want to put our vertices. So that goes there. And then we just want to tell it to that we're never going to change it. We're not changing this one, so we'll call it a static draw. And that should do it. This will not work. Why won't that? Oh, it's GL array buffer, is it? Oops. Dum da dum dum dum. Let me just check that on my notes. Because my notes are split now between areas. Yeah, that's the correct one. GL array buffer. Everything's gone red. Why? Yeah. It's already saying it here. There's a flip problem. And this is a problem with Java more than anything else. We're going to have to write a utility or something. It's not going to work like this. Ooh, it's just not going to work like that. So this doesn't work. It's just not going to work like that. So edit. Toggle case, no. So code. Yeah, I'll just do a block comment. That'll do it. So that isn't going to work in the format that it's in. Java cannot do what OpenGL is asking it to do. So we are going to write a utility that can do what OpenGL wants us to do. What should we call this? It's got nothing to do with rendering. So what kind of utilities have we got already? We already have a render utility, don't we? Well, that's to do with rendering. This isn't. This is to do with the buffers. This is to do with arrays. And a problem with arrays. Alright. Let's make a new Java class. Yay! And call it util. Yeah. And at that point, I think I'm going to have to read these notes a bit more. I think we've actually gone past where I only expected us to get up to mesh. I didn't expect us to get this far. So we're ahead. We're actually at the utility now. And this utility might prove a little troublesome. Because we're going to have to split it down into 2 bits. I'll tell you what the 2 bits are. They are public. Static float buffer. And that's, oh good, it's already imported it. Thank you. And this is going to be create. Float means floating point, buffer is just a buffer. So we're going to have to turn out our array into a float buffer. so it can go into OpenGL. Arrays can't go in directly. Create float buffer. That will be int size. So that's that one, and it returns a float buffer of that size. This is going to be awkward. Okay. I'll just write it straight then, because there's nothing here to it. It's just reprocessing of something that already exists. Because Java changes, and when Java changes, you want your code to change. So it's actually held in utils. Return buffer utils, sorry. That's the one. There we go, it's imported it. So if that changes halfway and you update your Java, it'll break your code. So to stop it from breaking your code, you write this class, this interpret buffer utils bit, just to make it work in future. Great, isn't it? This is why I don't use Java. Especially when it comes to... So all we're doing is we're returning the function that's given to us by Java, but we need to do it in such a way that in future it's upgradable, updatable. The functionality in the import doesn't break our program, and that's important. So I'm not testing that. Public. Did we test the other utilities? I think we did. We might be able to test this one. It's a static float buffer is what it returns, because that's what we want. And we want to do a create a flipped buffer. Yeah. Nice wording, huh? So we want to flip the buffer. And this is going to take in our vertices. Lovely. This kind of thing I don't like writing, because I'm now writing to change the language. This is making Java fit. So I need a float buffer. And we'll just call it buffer for now. Just do that for now. And we need to return buffer. Does that get rid of all the red squigglies? No. It doesn't. Does that get rid of all squigglies? Int mark, pos, lim, cap, float, int, offset. Ooh. No, thank you. I can't compile this. No, can't compile it. So all we can do is store that for next week, because that's where we're going to start. I'm going to try and work out a way of doing it. Why is that underlined like that? Don't know. Fine. So that's where we're up to. We're actually now forcing Java to take our mesh and repack it in such a way that we can feed it in to our graphics card. And that's what this is going to do. That's the whole purpose of this, is to take all the data, swap it into, well, change its order, and then flip the buffer. Flip just means that flip means the buffer goes from read to write. So at the moment, arrays you can read. You need to flip them to write them. Something like a output to a file or to the graphics card or whatever. So we'll have to flip. That's why it's called flipped, so that people know that it's not the read variation. In other words, reading into the buffer, you are writing out of the buffer. The opposite to flipping is, I think it's either I just think it's a dot reset, where this is dot flip. I think those are the two commands. So yeah, it's a bit messy, this. So I'm going to leave you with that. But we have successfully done a mesh test. I'm proud of that, actually. And we've done our vertex test, which means when we go back to these, we'll know that we're going back to files that we can rely on. I am thinking of testing window. There's not really much I can test in there, but there are quite a few things that we can test in there. Time I thought was a waste of time. Yeah. There's absolutely nothing going on in there. That's just getters and setters for times. Did we do the render util? Oh, that's right, we can't do the render util because it's just OpenGL commands. So there's none of that. Done. We've actually got quite good coverage now with our tests. Now, one of the utilities that comes with IntelliJ is how much coverage do you have from your tests. I just don't know where it is on all of these lovely, 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 lovely thingies. It's probably under Analyze. Yeah, you see, this can do quite a lot of things. Wow. It's even got data flow. And I'm going to have to look through to see how better to use our testing. And as you've already seen, I've started using Git now because I need everything saving out. So because everything's worked and I know it's correct, I can actually commit. Wow. Git. I want to commit all, please. Okay, game engine. So create all tests. Oh my god. There's stuff in here that I've never even seen. Oh god. I mean, there is a lot here that I have never even seen. This is what we get for Git. So we've got the initial commit, which I did earlier. So why is it coming up with that? I didn't ask it. I thought I committed that. Ah, right. I haven't pushed it. Never mind. I'll work it out. I'll go and work it out in my own time. Git is behaving weird on here. Is it here? Update project. Commit. Alright, well that comes to that. Revert. Okay, don't know. Because if you're using Git, you just usually commit and push. But I don't think I've got it set up for a remote repository, have I? Ah, yes. Okay. I shall sit down and start looking through all this. This is looking interesting, actually. It's starting to look easier to handle. I think I should do more with this. Yes. I like it. So, I'd like to thank everybody who popped by today, and I would like to thank you, my viewer, for staying with me all the time, and hopefully we've learnt something today. I know I have. I always do. Every time I touch a keyboard and do some programming, I learn something new. This Java business, well, we'll battle through it next week, and when we get out the other side, we will have meshes ready, up and running, with vertices, meshes, and, well, once you get the mesh, we're getting closer to rendering, and the renderer. Sounds good to me. Sounds good to me. I'm gonna keep, well, doing what I do, which is research and development. I'm gonna keep researching, I'm gonna keep programming, and I'm gonna keep on having fun. Take care, peeps, and make sure that you have fun.